Now we're looking at factoring expressions of the form of ax squared plus bx plus c, part 3. Let's look at another example here. We have 12r squared plus 7rs minus 7 minus 10s squared, Yes, so you may be wondering, what do we do now? We have two variables. How do we factor this? Okay, well, one main idea is let's treat the s square, or in the s, as constants, right? But then, once we do that, it's the same steps, right? First step, is there a greatest common factor among all of these terms? No. Is it a simple trinomial or a complex trinomial? Okay, it's a complex trinomial. A is not equal to 1, so it's a complex trinomial, and we couldn't get a GCF, right, among all of these. So, fine. So in this case, we're looking for two numbers that when we multiply them, we want to get what's positive 12 times negative 10 gives us negative 120, right? And when we add them, we want to get 7. Alright, so we're gonna break up the middle term, but we have to find out these two numbers. What are these two numbers now? Well, let's start with 120 and let's start breaking it up if we don't figure it out. You may know what these numbers are, but I think for most of us it may be a little bit hard. So 12 times 10 will give us 120. Let's continue breaking this up. Well, we know that this breaks into 5 and 2, and that's it. These are the prime numbers, and this breaks into 4 times 3, and then we can further break the 4 into 2 times 2. Alright? Okay, so we've got that tree. Now, let's see if we can combine these numbers to get our answer, right? So we know that, okay, 10, here we get 5 times 2, 10, and that would be what, 4 times 3, okay, we can multiply them, we get 120, when we add them, no, right? How about these? Okay, so we get 5 times 3, 15, right? And then we have 2 times 2 times 2 gives us 8. So 15 and 8, yes, we can combine those, right? So we have two numbers, right? 15 and 8. 15 and 8 that we can combine, right? And how do we combine them? Well, this can be plus 15, since our addition will have to be positive, right? And then negative 8, and then this also satisfies the negative 120. The product is negative, so both numbers will have to have different signs. Okay, so these two numbers, when I use these two numbers to split up the middle term. Okay, so let's look at this. Well, let's continue with this. So this becomes 12r squared, right? Now let's split the 7rs into plus 15rs minus 8rs, and let's bring down the negative 10s squared. Right? Okay, and then after this is basically factor by grouping, right? Let's group these two terms and also these two terms, which, by the way, you can group any terms. Actually, we will get the same answer, right? You can group these 12r squared with a negative rs, and this and that and that. We will get the same answer. I invite you to try it and see that we do get the same answer. Okay, so let's find what's common between these two. Okay, so these two, 12r squared plus 15rs, let's factor out what's common among them. It's the 3. Okay, between the 12 and the 15 is the 3, and among the variables is the r, so 3r is common between these two. Okay, so 3r times what, in order to get 12r squared, that gives us, that will be 4r, right, plus 5s, right? 3 times 5, 15 rs. Okay, and then between these two, well, they're both negative. Okay, so let's factor out a negative number. What's among the constants? I guess 2, right? and among the variables the s. So negative 2s is common between these two, right? Let's open up the bracket here. So negative times positive 4, right? Negative 2 times positive 4 in order to get negative 8, 4r, since we already have the s here. So negative 2s times 4r in order to get negative rs, and then positive 5s, right? Okay, now let's look at these two numbers once again. Alright, next time I promise I will make more space when I draw this leaf tree. Okay, so what's common between these two expressions? Well, we have the 4r plus 5s, and it's common among these two, so let's factor that out. So we have 4r plus 5s, right? And then we have 3r minus 2s. Okay, so we factor it out, and that's it. So we're done factoring this expression. All right, there are two more examples there in your handout. I want you to complete those, and if you have any questions, we'll take them up in class. All right, see you later.